There are 4 variables that will directly affect the kinetic theory of gases. We'll be working with pressure, volume, temperature, and amount of gas, which we'll be using moles to describe. There are gas laws that describe the relationship between a few of these variables. So when temperature and the amount are held constant, we can just worry about the pressure and volume relationship. The gas law that describes the relationship between pressure and volume is called Boyle's law. It says, if the temperature and amount of gas in a container are held constant, the pressure of an ideal gas is inversely proportional to the volume of the container. As the volume shrinks, particles will collide with the container walls more often, and that is what pressure is. Gas particles hitting container walls. We've all seen Boyle's law at work before. This is an example. When we're squeezing the bubble of bubble wrap, there's air in there, and we're decreasing the volume of that air. The air pressure inside increases until it pops. That's Boyle's law. This is one way to express Boyle's law. Pressure is inversely proportional to volume. Here's another way to write that equation. The following equation can be used to calculate the pressure or volume of a new state, as long as temperature and the number of particles remains the same. This is the form of Boyle's law that we'll be using. Let's look at a Boyle's law problem. Here we have a scientist that has 2 containers. Container A is empty, and we know the volume, 25 milliliters. We have container B, which contains our gas. Our gas initially has a pressure of 1.5 atmospheres, and it has a volume the same as container A, 25 milliliters. So that's giving us our initial conditions, P1 and V1. Initially, we have a volume of 25 milliliters. We also know our pressure initially, 1.5 atmospheres. The scientist then connects these 2 containers using a 5 milliliter tube. What is the pressure throughout the new system? In order to know what the new pressure is, we need the volume. The new volume means that we have to add the volume of container B, container A, and the 5 milliliters of tubing. Now that we have 3 out of 4, we can solve. I'm just going to be plugging in the variables that we know. Initially, 1.5 atmosphere per pressure and 25 milliliters. That's going to be equal to our new volume times our new pressure. All we have to do is take 1.5, multiply by 25, and then divide by 55. As you can see, I'm not too interested in the units because we start with milliliters, we end with milliliters. We start with atmospheres, so our final pressure is going to be in atmospheres. If our volumes had different units, we would have to change one of them in order for them to match. So here, pressure 2, you can use your calculator. If our volume is increased, that means our pressure should decrease, and that's what we see here. That's our new pressure.